having this market conference will help build better rapport between those of us who build apps, work with graphics drivers, and really help build user space. So let's have some great discussions going forward, and see how things go. So, Alex, if you want to go and get your slides up, and we can get started here in a minute.
All right. Cool.
I'll turn myself off of.
So, will you set up the slides, or can I switch them over?
You should be able to switch them over. They're already uploaded, so you should just have to you hit the plus button and then hit the upload, or where it says upload, it should already be there.
Alex, I'll put them up for you and make you presenter, and then after that, the next speaker.
Oh yeah, you need to be presenter. Yeah, sure.
There you go.
Oh yeah, that works. Oh wow.
There.
It rendered kind of poorly, but
You're our presenter.
all right, now it works.
The platform converts all your artwork back into SVGs and then the text back into text. So sometimes
It's not looking great, but whatever.
I think only you can notice. It looks good from here.
Oh, the background is supposed to be all like gradienty and stuff, and the gray is just looking bad. But whatever.
It looks fine on my end. I don't.
All right.
No, I've seen what he's now talking about. You can take a image capture of the front slide and then upload that here if you want.
It doesn't really matter.
Yeah, it looks good. Alex, don't worry about it.
It doesn't really matter.
If those of you on Rocket Chat, you can join our application ecosystems MC channel, and if you have any questions, you can either, of course, by now it's almost near the end of the conference, but if you don't know, then you can ask questions on Rocket Chat or on the chat here on BBB, or if those of you watching YouTube, you can post there. I'll monitor questions there.
All right, should we start or?
Yes, go. You got it. You had the con.
All right, so my name is Alex. I work at Red Hat in the desktop group. Normally that means I'm doing GNOME stuff, but for the last 3-4 years, I've been working on this thing called Flatpak, and it's kind of a desktop version of containers. And I think here at Plumbers, most people are more aware of how containers work, and in particular Docker. So this is going to be a talk about how Flatpak works and how it compares to containers like Docker, and also some issues we have in the ecosystem that would be cool if we could find better ways to do, and ideas of how to solve these issues. So, and also, I'm sorry about the background. It's not supposed to have those gray triangles. They kind of got converted badly. So, but that doesn't really matter. So, what is Flatpak? I have this long description. It's a distribution-independent, Linux-based application distribution and deployment mechanism for desktop application, which is kind of a mouthful. So I'm going to try to unpack some of these. It's distribution-independent in the sense that you should be able to write your apps and build them as Flatpaks and run them on any distribution. And obviously, like Flatpak itself also has to run on any distribution. But it should also be possible to build your apps on any distribution. We have a build system that is containerized. So if you build your app on Debian or RHEL or whatever, it should produce the same bits every time. So you can work with people in different distros, and they should be able to build the same thing in the same way. And also, obviously, by version, I mean, you should be able to run Debian, some older Debian with a newer app, and then upgrade Debian. It should still work. It's Linux-based because we use all these kernel features for containers. But that doesn't necessarily mean we can just use any kernel features that we want, because an important thing about Flatpak is that we can use it to run on older distros. We can run the newer app on older distros. And that means we can't have any hard requirements on kernel features. I mean, I listed a couple of old distros here. And while we don't have any specific kernel version, if things of this age starts breaking, that's something we don't like. So, we don't support ancient things, but these are like 4 or 5 years old things. It's a distribution mechanism, meaning that you don't have to download your things on the side and then install them. It's a system that can both install and keep things updated inside itself, and it's a decentralized distribution mechanism too. Like we do have FlatHub, which is kind of a default place for free and open source apps, but it should be free for anyone to set up their own repository, their company or their project or whatever, and that repository will not have be less important than say FlatHub. It's also a deployment mechanism. Obviously, well, when you have installed something, you need to be able to run it, and to run it in a way that we can make independent of the host, we have to run it in a control environment, and that's where we get this whole container thing. So we naturally have to have a container, but we also want to have a container because that way we can improve security in the sense that we can protect apps against other apps and also protect the user's files from apps. So we do have the default sandbox. If your app doesn't have any specific permissions, it's very, very tight, but also kind of useless because you can't talk to the X server without it, and a lot of apps are X. So apps can ask for more permissions, and then we ask the user if it's all right, and if they do, then we can then we grant those out automatically. It is focusing on desktop applications, and by that I mean it focuses on running in a graphical desktop, running graphical applications. It's quite possible to run command line apps too, although it's not super streamlined. But the focus is on UI stuff, and that leads to certain context of running things. Like the applications can never, or the system as a whole can never require root passwords, for instance, because the user might not have the root password or sudo rights or anything, and even the opposite is true too. We cannot accidentally allow or grant the user any kind of root permissions because he might not be supposed to have it. I mean, if you have someone who is a pure user, you can't grant them Docker access because Docker could give you root permissions, but we don't do anything like that. We also automatically integrate with the desktop. So the app just, once you install it, it just appears in your menus. When you run it, it will get access to, the X server, the Wayland server, Pulse Audio, dbus, all the kind of things that a desktop app expects. I mean, it's certainly possible to run, say, Firefox in a Docker container, but it's not automatic. You have to know all about the X sockets that you have to bind in the right place and set the right environment variable, whereas this is just automatic. It's also very different in the sense of lifetime of applications. Lifetime of a container is kind of tightly maintained, whereas these things are just like, you click somewhere, you open a file, suddenly the editor opens and it will be running until you exit it. And there's no knowledge about what's supposed to be running. Should we restart it? There's nothing like that. It's very transient, very ad hoc. And there's never any sysadmin kind of, we can't rely on, say, the sysadmins to go in and regularly clean out old stopped containers like in Docker. That just doesn't work. Everything has to be fully automatic with no maintenance. So I want to talk a bit about how Flatpak differs from containers. And by containers, I mean Docker, because that's what most people think of for containers. And I think the easiest way to start with is to take a look at the file system layout from the inside of the container. In Docker, you typically run like a REST server or database or something. So it's a very small thing that has not a lot of dependencies, and all the dependencies are handpicked, right? Depending on what kind of thing you're running. Generally, also they are developed, like containers produced by the same people that kind of run it. And it runs as a daemon user. I mean, it might be running as root or a daemon or something, or as root in the container, but not root outside. But it's not like a regular actual person user. So it has all sorts of privileges in the system. It writes in var log and whatnot. So we cannot we can't know what it will do to the file system at large. And it doesn't really need any kind of integration with the host at all. However, it does integrate with other containers, typically via DNS and port forwarding. Sometimes there are volumes if you have to store data, but not generally. There's basically no access to the host file system, and that's a feature because we want to be able to run the containers on any kind of host, and that shouldn't affect how the app works. And also, when we run out, when we roll out an update, someone get paged if it goes down or if it's slow or something. So it's very dissimilar from desktop in that sense. So the result of this is that we have a very simple layout of the file system. The app brings, yeah.
Sorry to bother you. There was a comment by Frederick talking about the use case for development environments on the slide you just covered. I was wondering if you could address that for a second. Or Frederick, if you can voice up what your concern were. Yeah. The comment is just except for the use case for development environment. I thought that was an interesting comment, but I didn't know the context without losing track of that.
Yeah, I don't really know. Oh, he's typing somewhere.
Yes. Suspense he's going to talk about.
This is about Docker stuff. Yeah. I mean, it's certainly possible. I mean, generally, I'm talking about generally how you use Docker, though, in sense of a cluster or something, and not necessarily how you would use it as a developer. I agree as a developer. If you use it just to, debug or develop, it's quite a different point of view. But then you kind of are at the edges of what Docker is meant to do. And also, I mean, at the edges of you can do the same in Flatpak, but it's also kind of not what it's focusing on.
So the file system coupling is a good example. Yeah, I've abused that myself as well, where you just you have your Git repository locally. You don't want to move it in the Docker as well, so you just sort of expose that. And that's a good example.
Yeah, and the way this results in the design of Docker is that the image contains everything, and you can bring whatever you want, and you can basically lay it out however you want, and it is unless you manually do stuff. completely independent on the host file system layout. In Flatpak, what you typically run are more like desktop apps, Firefox, Spotify, Gedit, and these expect a very special kind of layout. They expect it to look basically like a Linux desktop distro. With, for instance, app data being read-only. I mean, user share is not really read-only, but in terms of a user writing there, it's not possible. So all the app state goes into the user's home directory, which is, this is just how things work. This doesn't have to be any work to make it work. So this is how it's always worked. And the file paths, if for whatever reason you want the app to have access to, say, your home directory or some other directory, it has to have the same location in the sandbox as on the host. Because, like, if you click on a file in a file manager or start something from the command line, and you switch over to the sandbox, and if you load the same path, and if it's not mapped in the same way, it would be extremely confusing for the user. Like you were opening this home Alex, blah, 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 and suddenly it's not there because we started an app. So it's very different. So basically, the requirements are such that rather than the sandbox being independent of the host, it's very tightly tied to the look of the host. And also, where a Docker container doesn't have a lot of dependencies, typical desktop app do have a lot of dependencies. So as a result, the layout is completely different. And what we do is first of all, we have the app in a place called /app, which is a new top-level directory. So hopefully no one else has that. So it will not run into any conflicts with anything. And in /user, we add something called a runtime. And the runtime it's like a mini distro or a base image. But it is it contains shared versioning, shared dependencies, just like a base image does. But it's versioned separately, so the app can ask for a specific major version of a runtime, but it will still get updates to that. So we can have like security updates to the runtime with the static or non-changing app. And we do have some private things, like /temp is for security reasons separate. So we have a per app temp, but also like proc and run and stuff are specialized. But everything else is mirrored from the host layout. Or, it's not visible at all. So, but if you have access to any particular areas of the host, they get mapped in exactly the same way as on the host. And there's this per app state directory in .var app, which is by default the only way you can store persistent data. Obviously, if you have, for some reason, more permissions, you can write wherever you have permissions, but that's always available. And also we have some host data that is always available, like icons and fonts, because these are kind of useful and they're safe to expose, basically. So in terms of implementation, the requirements for Docker basically requires you to be able to write anywhere. In that, for that to be efficient, you have some kind of union style file system or equivalent like a device mapper or something. So you have one mount, which is this image, which is some kind of union style overlay FS2 these days mostly. And this is mounted by the Docker daemon that to set up the root basically, and then you root into it basically and track the container. And when the container dies or the last process dies, you unmount this thing and clean up after it. And the way we use union style mounts means we share data on disk between different containers that use the same image. And additionally, we can use layers to have parts of images shared between each other. But it's, some sharing, but it's not as good as what we will get for Flatpak. You'll see with this, because in Flatpak, instead of having it set up from the outside, the actual setup happens inside the container. So the root directory is a tempfs that is only visible, but it's mounted inside the container. So it's the only visible amount of it, and the kernel will basically reap it when the container exits. And then we bind mount stuff onto this, like app and user are just bind mounts of regular directories, and the other host directories are also just we create the right prefixes in the tempfs, and then we bind mount things into place. And all of this will just get torn down automatically by the kernel when it exits. The only thing that's not fully automatic is if some app got updated or uninstalled while it was running, we keep the old thing around until the last process exits that uses that particular image. We have the PID1 and the namespace taking a file lock on the image, so we can see which ones are in use, so we can garbage collect them. And the really cool thing is that we use the system called OSTree, which is a content address store, and everything that is installed in Flatpak is in one of these OSTree repository on the disk. And that means any file that happens to be identical between two apps or between two runtimes will hash to the same value and thus be shared. And so we get this perfect sharing of files, and then the actual directories that we use as images are hardling farms back into this repository. So that means we get perfect sharing of identical files, both on disk and in page cache, since two files being hard linked means they use the same page cache data. So it's pretty good in terms of using less memory. If you have a lot of, basically all the apps will be using glibc, and they will all share the same page cache pages for that. That's pretty cool. So some technical details about the Flatpak Sandbox. We use for two reasons, as I said before, because we need it and because we want it. And everything is based on unprivileged user namespaces and this no new privs flag, which allows unprivileged user namespaces. And that means there's no root anywhere. Like it runs entirely as your user, as your UID. And in for instance Android, there's like a UID per app, but the way the Linux desktop works is we just cannot do that. We have to have everything the same UID. So we have something else called the application ID that is kind of the security domain of everything. So we have app permissions which are basically per app ID. So if org.gnome.gedit has access to a home directory, that's a static permission that we set up at launch time. It's basically part of how we set up the kernel when we launch the app, and we can't change that afterwards. But we also have interactive dynamic permissions. Things like access to a camera can be dynamic and decided, at the place where we want to use the camera. We can just ask the user whether it's okay or so, or just interact in a natural way to create dynamic permissions, which is something you just cannot do in Docker because you can't. There's a question here. So the home directory is not available by the user. So there's a question here if you have access to the home directory read-write, and that's not by default true. By default, you only have access to this. I can imagine it looks like you have access to var app ID, but actually all you have access is this final directory, and the rest is just empty directories on the tempfs. So unless you have explicitly asked for home directory permissions, you don't have any permissions for the. The question was, if you have access to your home directory, can you use not, write something somewhere like a bash dot profile or something to make the host side run some code? But it's not. It's true in general that if you do have write access to your home directory, you can basically escape a sandbox super easy. But by default, we don't have that. We don't have full home access. Only this particular per app directory is accessible always. Anyway, so the sandbox is set up by this tool called Bubble Wrap. It used to be part of Flatpak, but it's been extracted because it's actually pretty useful in general. It works just like Flatpak. So it starts with an empty tempfs, and then you can slowly build up your entire thing. And it's very useful for shell use, like shell script, or just if you want to run something in a limited environment. It's like Shroot on steroids that works for unprivileged users. So in this example, we bind the host/user on top of user in the sandbox. We create a symlink with this value at this point, and then we mount a proc and a dev, which are specific to the sandbox, and we unshare the PID namespace, and we run bash inside this. So basically, this will give you a bash in a system that only has /user, which is read-only. So you would be able to write stuff in, say, the rest of the system outside user, but it's only in the tempfs that you can't see anywhere else. So Bubble Wrap also has a set UID mode. So I kind of lied about there not being any root access. There is, if your system, like if your distro doesn't support unprivileged user namespaces in the kernel, you can, if you want to, run Bubble Wrap set UID, and it will kind of give you a minimal unprivileged user namespaces that are limited to just the things that Bubble Wrap exposes. We use in Flatpak, we used unshared PID and user namespaces. We also, by default, unshare network and IPC namespaces. However, network is used by a lot of people, so it's permissions to enable that. And IPC that's basically the System 5 Unix IPC stuff, which are kind of crap. But unfortunately, the shared memory extension requires that. So most apps, unfortunately, have to share the IPC network, the IPC namespace. I wish that wasn't true, but until we get full Wayland everywhere, that's going to have to be true. We use seccomp to block various, weird or unnecessary syscalls. I'll list a bunch of them here. We also use it to block the keyring because that's not quite namespace. It doesn't work well with namespaces. And we also, for security reasons, have to disable recursive namespaces due to various things in the portal implementation, kind of relying on clients not being able to modify their file system hierarchies. By default, we also disable multi-art, perf, ptrace, but these are all permissions. I mean, in particular, ptrace is important if you want to run an IDE or do any kind of debugging or things like that. We don't use cgroup a lot. Historically, cgroups v1 hasn't really been useful, unprivileged. We do create a systemd -user scope if that's running, but right now it's hard to do more than that. We default to a pretty empty dev, but optionally we can add in some extra stuff, like GPU device nodes, KVM device node. And if your app is doing weird hardware stuff, you could also get the whole dev if you want to. That sounds really horrible, but in practice, it's not necessarily that bad because most of dev is not really accessible by the user. It's it's only accessible by root. We have various socket types that we are able to automatically forward and set up inside the Sandbox as needed. I list a bunch of optional here, but at least the ones at the beginning, like X and Wayland, are basically going to have to be enabled by everyone. So that's not really optional. But if your app does Wayland, you can optionally out of X, for instance. We also set up a P11 server by ourselves to forward the root CS certificates to the client in a read-only way, which is standardized. So that's kind of cool. So if you have custom CS certificate roots on your host, they get forwarded into the sandboxes. Also in the list here we have dbus, but those are full access to these sockets, which is highly unsafe to do because there's all sorts of stuff on the session bus that can allow all sorts of operations that are not secure. So by default, we do give dbus access, but in a filtered mode. And we have this proxy that we run to generate, the proxy will listen to calls from the sandbox and forward them as needed to the real bus. So by default, you can talk to the bus. I mean, you can connect to the bus, and the bus itself is an object on the bus that you can talk to. And then you can get messages by anyone who is allowed to send messages to you. And you can own your own application ID as a name on the bus. And coincidentally, the Flatpak application IDs are the same format as the dbus names. And there's this namespace called org.freedesktop.portal. Which is free for all. Basically, any app can talk to anywhere, anything that exposes something in that, and that's the basis for implementing portals. But all of this is obviously extensible, so you can add permissions that says yes, I have rights to talk to a specific service on the bus, or B, own a different name on the bus. And we also have similar filtering for the accessibility bus and the system bus. Although the system bus is not necessarily used a lot for desktop applications. So portals are essentially dbus services that happen to be in this namespace where anyone can talk to them. And that means that they don't really have any kind of security checks by the system itself, so you have to they have to be very careful about enforcing policy inside the portal itself. And we do this based on peer credentials, and like you connect via Unix domain sockets, and we can get information about the other side, and we can decide based on what's talking to us whether it's allowed or not, or whether we should do some interaction to ensure it's safe. And we have a bunch of portals. I think the easiest one to explain is the file chooser portal, which is part of the XDG desktop portal set of portals. And the way it works is that if your app doesn't have access to any of your files, it instead asks the portal for it to let the user show something. So the portal, which is outside of the control of the app, will open a file chooser, and that will work as usual, and eventually user picks a file, and then that kind of becomes an implicit permission for the app to access that particular file. So we don't ask, do you want this app to have access to your home directory, because that's not very unsafe. Instead, it's also not very good user experience to ask, like, do you want to allow this or that, because people always say yes. So instead, we have a very natural flow where we open a file chooser exactly when the user expects one to show up, and if the app tries to exploit something showing a file chooser is pretty safe because you pretty much guarantee that the user will not like select an important secret file inside this random file chooser that appears. So we have several of these kinds of portals: file chooser, print, dialog, open URI, screencast, screenshots, all these kinds of stuff. And we have multiple backends for them. So if you run a KDE desktop, you get a KDE file chooser. If you run a GNOME desktop, you get a GTK one. And we have this document portal, which is really part of the XDG desktop portal, which is how we implement the file chooser portal, basically. So it's a portal paired with a fuse mount where you can export a file and then set per app permissions on that particular document. So that's what the file chooser portal does. It creates a document for the file, and then it grants the caller app access to that particular document. And Flatpak itself ships with a portal that extends some of what it can do. Like you can do sub sandboxes, which are not recursive sandboxes, but rather, sandboxes on the side that happens to have the same structure as the original one. And that way we can work around the forbidden recursive sandboxes. And we have self-updates. You can get an event when there's a new version of your app available, so you can restart and whatnot. So that's a short description of how Flatpak works and how it differs. And now I'm going to try to talk about some of the issues we have. I mean, Flatpak work reasonably well, so these are not horrible issues, but it's still things that some of them are things we could do better, some of the things that we think have to be worked on in the system. One of the things I really would like from the kernel is some way to tag containers. Like in our case, we want to tag with the app ID. So the container management system or whatever, we want to start something and ensure that every child process in that container is tagged by this string, basically, and that you can read back the tag via, like, if the app talks to a portal, the portal can get back this tag. And the only real ways to do this right now is SOPR creds, SOPR sec, and like the C group path. And of these, really only SOPR creds work well enough. Like, not everyone wants to use SLinux or have to tweak SLinux for their container system. And C groups don't really work yet for unprivileged stuff, or at least C groups v1 doesn't work well. So what we use is SOPR cred, and that gives us the PID. And that way we can find the in proc PID, we can find the root of the namespace. And what we have there is a file called .flatpak.info, which is set up to contain information about the container, like the app ID, in a way that the app cannot change, right? So we can trust this thing. If it's there, we can trust it. If it's not, we assume it's something else, like the host process or something. The problem is that there are tiny races whenever you use PIDs for PID reuse and things like that. I think in practice it's fine, but there's been some work, I think, on PID FDs. I don't think there's anything landed, but maybe we can work around the PIDs. Here's one of the reasons why we cannot allow the app to restructure its namespace. So that's one of the reasons why recursive namespaces isn't allowed. And if we had some other way to do this, maybe we could do so. So this is something I wish we had that worked better. Another issue I have is with abstract sockets. They're currently bound to network namespaces, which is kind of, I mean, I guess they had to be put somewhere, but it's not really right. I mean, sometimes you want network access, but not to see all the host abstract sockets, and sometimes you don't want see the network, but you do want some abstract socket. And also abstract sockets are lame. They're like this 90s thing where you didn't want leftover sockets in the file system laying around after reboot. But these days we should just use like run or some tempfs thing. So I don't know. I wish I could disable abstract sockets separately from the network namespace. But really, we should just make sure that nothing ever uses abstract sockets. We do support network either or, like you can get nothing or you can get shared network namespace with a host. I really would like some kind of in-between thing, maybe like a natted thing where you can call out but not get called into, or even like IP filtering. I don't know how useful that would be in a desktop environment, but maybe limiting yourself to local network, things like that could be useful. The only options for this right now seems to be this slurp for netns thing, which is, you know, some insane hack where you run a slurp daemon and then you fake a serial connection to your container and do stuff there, which apparently works pretty well, but it seems kind of hacky, and it's yet another process that we have to have per container or something per some kind of filtering settings. I think there's a socket filter for C groups now, but it's root only. I mean, it was, at least last time I looked. It would be cool if that was accessible for non-privileged things, because that might allow us to do this in a better way. Another thing that would be nice, but not necessarily super important, would be unprivileged access to overlay FS2. I don't think you can currently do that in an unprivileged user namespace, but we mainly use UniFS, and we use a Fuser-based overlay for building stuff. But having a real kernel version would be nice and more efficient. I don't think it's currently. I don't know if anyone knows why it's not available in unprivileged user namespaces. Apparently there's security issues. That's always the case, though. I hope someone is working on it, because that would be. It seems like it should be possible to do safely, but maybe not. All right, so it seems to be a question of just doing the work. That's always the case, though, but hopefully that happens. This other thing called FS Verity, I really like. I haven't really used it a lot, but we have some initial work in OS3. It basically allows you to make files immutable, which is a perfect match for OS3. And then we have Merkle trees to verify that they don't change afterwards. I think it's only XT4 supported right now, but if we had support for this, I think it would be really good in terms of ensuring that things don't accidentally get changed. And also, I think we could use it to allow signatures on apps. So you could say only allow running Flatpaks that are signed by a specific app author or something like that. So I think this is super cool, and we should try to make that work everywhere. I believe Android is using this too, so maybe there's more interested in it. C groups. I need to actually look at C groups v2. I think it will allow us to do a lot more than we used to do. And C groups v2 is actually enabled by default in a bunch of distros now, so we should be able to take advantage of that and do things like CPU or memory limits, and even maybe IO priorities and things like that. This is something I just have to look at, and I haven't had time yet. Here's another thing that I sometimes see people wishing for. Like they want to say grant access to all the joysticks to the sandbox, or all the some kind of USB device or whatever, some kind of device basically, and they want this to be dynamic. So if you plug in a joystick afterwards, you would grant access to that thing later. And currently we kind of drop all the privileges for bind mounting stuff, so we don't have any like babysitting daemon that can go in and modify existing things. So currently we can only do this if there's like a subdirectory in the kernel or on the host /dev. Like in dev.gri, we can mount the entire directory, and then any updates in that will get propagated into the sandbox. But for USB, for instance, it's much harder to do that. I mean, sometimes it just doesn't make sense. For actually, what most often comes up is I want to give joystick input to my app, and that actually I think should be better solved in Wayland, for instance. If joystick input was routed through the Wayland daemon, then we could have things like focused windows define what apps get the events, which is a much better security model than whether they have access to it or something. So two questionnaires. Some desktop apps set up background services that are auto run on login. Think of something like Dropbox UI with background daemon. Can they do so in Flatpak such that they run on login? Not in Flatpak itself. However, there is a portal there's like a background portal where you can request your thing to be started, and then that will be. I mean, it will be up to the portal back and how you handle that. But I believe the GNOME one, for instance, just asks you whether this is okay. So yes, it is possible to do that. It will not happen until you run the thing once, though. Like you can't do it on installation. But it's something that you can sort of do. And Eric asks, for portals, have you considered having a named Unix domain socket in each container? So the way it works right now is that we run this dbus proxy, and that has to, I mean, to be secure, that the proxy has to run outside of the container, so we can't like ptrace it or do anything weird with it. So we do have a custom socket basically inside the container that talks to this proxy instead. Could we? I mean, I guess we could sort of have that tag things. I don't see really how we could forward that over dbus though, because in the end, it would just be forwarding a dbus message, and it's hard to add something to that in a way that it could authenticate the app. And also, this kind of goes with the next one, I think. Yeah, I really would like this whole proxying to go away, because I mean it's stupid to have an extra and we already have a process for the bus. That's the dbus daemon, and if that could do the filtering instead of this proxy, then we could have a lot less copies and a lot less processes. And actually, there's an like a work in progress implementation of this, and that does contain some of what you mean, where you can sort of tag. I mean, in this setup, you would have to ask the dbus daemon to create its own domain socket, which is specific to a container, and then that way you automatically get this tying of a dbus client with an app ID. So that in that case, that will be solved. But unfortunately, like it was 2 years since anyone commented in that dbus implementation pull request, and also these days we have other dbus implementations like dbus broker. So even if that got implemented, we would have to update those. I do, however, think that it would be cool to do that. We can still use the proxy for older stuff. I think we're running sort of out of time. Pipewire is this newfangled thing. It's the shit, and everyone should try to make it work and basically build it in their into distros and package it. I still need some work to integrate it with a portal. It is Sandbox aware, but more so in that you can create connections to it that have limits set on them. So we need the portal as an in-between. So if you ask the portal for like, give me a camera, it can return a connection to the Pipewire daemon that only sees a particular camera, for instance. So there's some integration work there, but there's also some development work just to make Pipewire kick ass and be available everywhere. GPU drivers are a giant pain in the ass. In particular, the NVIDIA one, where you have to have an exact match with the kernel driver and the user space driver. We have this hack where we basically ship versions of the user space driver, and then we look in proc somewhere for the exact NVIDIA version and pick the right one, which is sort of a hack. What I really would like to do is to be able to use the host driver, but that opens up a can of worms and all kinds of ABI issues. Like, can't just load a driver from the host because it might be using a libLLVM or a libstdc++ that is not compatible with whatever is in your sandbox. So it's a pain. There is this libcapsule project which tries to use DLM open to basically open a driver or any kind of library in its separate stacks. It's like its own symbol namespace, completely disconnected from the rest. And I don't know the status of that, but there's some interesting work, and I think we should need to follow that and maybe move towards using the host drivers for OpenGL stuff. And I think that's basically my slides. So if there's any questions.
We're kind of out of time for questions, but if you can hang out on the Rocket Chat and anybody wants to continue this conversation.
Yeah, I'll hang around for a bit.
So that would be the best. In the meanwhile, if you want, we'll get George's going. While I'm doing that, I can. You can, if anybody wants to ask questions real quick, I can do that while I give George's presentation presenters access.
Hi there. I guess you can hear me now? Yes, I think.
Yep. But we can't see you.
Okay, fantastic. Sharing my webcam, just a second. All right.
Did you get presenters access, Georges?
Not yet.
I have to find you. That's the problem at the moment.
So didn't get anything here.
Oh, you got it.
It does look like my slides are in, but I'm not still. Okay, looks like I am now the presenter. Can you see this red dot moving around the slide?
Yes, well, your background is orange, so it's hard to see, but yes, we can see it. Go ahead, George.
Okay,
Thank you very much.
Okay, fantastic. Thank you so much. All right, cool. Welcome to this presentation. My name is Georges Stavrakos. Can I start? I guess we're out of a bit too late now. So I'm just gonna go ahead and start. Okay. All right. So my name is Georges Stavrakos. I work as a developer at Endless OS Foundation, to which I thank for allowing me to prepare for this presentation, prepare some demos for it. So let's see how it goes. So welcome. Hi. So today we're going to talk about Mutter and GNOME shell, and I realized this is a large topic. Being a compositor, I understand. I can appreciate how it can be intimidating, since I don't think we've had many such presentations and talks and discussions here on LPC. This is my first time here as well, so I tried to set a route with my slides and my presentation in such a way that I'll cover a large range of topics that I think are related to and interesting for this conference, and I hope one or more of them can spark a discussion, questions, suggestions, or maybe even prototypes afterwards. It'll be fantastic. Yeah, hopefully things will be interesting for us. Mutter is extremely large as a project, and I may not be the best person to ask questions about specific topics, but I think I can I can answer some things pretty decently. So let's go ahead and start talking about what's Mutter. Mutter is basically a compositor, but also a library to write compositors. As a compositor, Mutter itself is super tiny. It doesn't have a lot of features. It's just a background plus window management stuff. The real deal is that it supports plugins. And in this case, and throughout this presentation, every time I talk Mutter, I say Mutter, you can think of it as either GNOME shell, which is essentially a Mutter plugin. It uses libmutter and adds a bunch of stuff on top of it. But you can also think about it as, I don't know, Elementary's Pantheon, which also is a compositor based on Mutter. Mutter stands for Metacity plus Glitter, which is a toolkit. I'll be talking about it more afterwards. And currently, Mutter can handle Act 11 and Wayland. In this presentation, I'm going to focus more on Wayland, since it's what I'm more familiar with. I'm kind of a spoiled kid. I started contributing to Mutter after Wayland has a pretty decent implementation already. So I'm fortunate enough to not have to deal with Act 11 anymore, almost entirely. So there's a bunch of stuff that compose what we call Mutter, no pun intended. So let's start with Mutter itself, which is the compositor. Well, the whole purpose of a compositor is compositing stuff, you know. So we need clients that send data to Mutter, and Mutter composites. It uses libwayland server to do that. Of course, clients on the client side, it uses libwayland client to communicate stuff. But most importantly, in an ideal world, I'm simplifying stuff here. So I'm thinking about only the free and open source stack. So clients draw stuff on a frame buffer using like Mutter or another free and open source graphics driver, and send this buffer to Mutter, which then composites it with like a background, in the case of GNOME Shell, a top bar, and some window management stuff, some cool effects when you minimize or maximize your window, or when you drag them around and do all sorts of crazy stuff with it. And of course, drawing stuff means accessing the hardware to some level. But then after sending like a buffer to Mutter needs to composite it. And it does compositing using Flutter and Cargo. I'm going to cover these layers to some depth later on. Basically, Flutter is a toolkit, and Cargo is an OpenGL abstraction layer. So Cargo is like nicer GL. That's why it's like over here. Oh, I can actually draw it here. Fantastic. So we got Cargo here, which, again, thinking of simplifying stuff, thinking about the free and open source stack on NVIDIA, it's a completely different scheme. It's a completely different way of handling things. But yeah, Cargo is basically nicer OpenGL. Flutter on top of that, and then Mutter on top of Flutter, doing all the UI management bits. And the cool thing about Mutter is that after, Mutter also has to draw itself on the screen somehow. So you got the client texture, client draws something on the GPU side, and then the client tells Mutter that it has drawn something on the GPU side. Eventually it shares the texture with Mutter, and then Mutter also has to draw stuff on top of it. So it does the compositing bits also with OpenGL. And then in the specific case of being a Wayland compositor, Mutter also handles the low-level bits. So it uses GBM to create buffers, and KMS to do mode setting and page flipping, and etc. And of course, being a compositor doesn't mean you only have to draw, but you also, Mutter has to read events from the kernel. It does that indirectly using lib input. And it then sends these events, these input events, to the clients, also through the libwayland server route. In the case of Wayland, clients cannot access anything, cannot read events that are sent to other clients. This is private information in terms of who accesses it. Mutter has access to it, and the clients only know what they're supposed to know. On X11, that's a completely different scheme. Mutter is basically the X server is the compositor in this case, and Mutter is kind of a special client. It's a client with privileges. Being a compositing window manager, not the compositor. But it still lives in the same level as other clients. So the chart looks quite differently. So let's have a quick look at Cargo. So Cargo, as I said, is basically a nicer OpenGL. Most of its APIs are made to look more object-oriented, and they're more idiomatic when it comes to like glib and the GNOME stack. Most of it centers around Cargo context and Cargo frame buffer, which is interesting. Cargo predates Vulkan by many years, and yet the abstractions inside Cargo are surprisingly similar to Vulkan. Has a swap chain object that behaves more or less like the Vulkan swap chain, has a explicit image types, an explicit context. It's incredibly similar if you think about it. It was an independent project before being merged with Mutter. It's actually Glitter and Mutter. There's not much talk about it. It does OpenGL stuff, but nicer to use API basically. And then we have Glitter, which is the toolkit that we use for drawing. So Glitter was born as an application toolkit, OpenGL based, of course, being based on Cargo. It's OpenGL by nature. And over time, it grew like a very large pile of hacks in order to become a compositor toolkit. But at some point, it got so distorted that it was better to basically fork it inside Mutter. And over time, we've been slowly stripping it out of client-side application toolkit APIs. So many things don't make a lot of sense when you're a compositor, but make sense when you're an application. And we've been removing those things and focusing and reducing the code base to be like a compositor-only API. So Wade's asking here, any thoughts, plans to use Vulkan instead of Cargo? We don't plan to replace Cargo. What's very likely to happen, if it happens at all, is that we'll grow a Vulkan backend for Cargo, because Cargo also has backends. So it has like BigGL, it has EGL, GLES. It had in the past EGL, KMS. Now it's part of Glitter. Sorry, it's part of Mutter. So if anything, it's gonna be another backend for Cargo. So it's gonna be a Vulkan backend for Cargo, and GNOME shell/Mutter won't even. Well, Mutter might need some like hand holding, as it does directly access EGL stuff when running on Wayland, but we do. It's not that hard to add. It's a small part of it. Hopefully that answers your question. Thanks for asking, by the way. Yeah, Glitter animation framework has a very cool, easy to use and expressive animation framework that allows us to implement basically all the GNOME shell animations using like implement effects like blurring and etc. through shaders. And it also does input handling. In fact, now that it's a compositor API, it's a compositor toolkit. It contains input abstraction layers. In the past, when Glitter was an application toolkit, it used to handle input itself. Nowadays, it has all the abstraction layers in terms of Glitter seed and family, and Mutter implements these abstractions differently for when it's running on Wayland and when it's running on as an X11 compositing window manager. But on Wayland, of course, it uses lib input and XCB, and on X11 it uses X11. X11's when it's running in as X11, everything is X11. As a toolkit, it follows the traditional update cycle. I'm not sure if everyone's familiar with that, but I'm giving it a quick glance at it. Layout, basically, you put UI elements on the screen, you position them, have their size, and then you paint all these elements. So you paint a label as white, and then behind it, a panel as black, and then you want the screen, the texture of the screen somewhere, positioned somewhere, somehow. And then you pick, you run the pick phase, which is like figuring out what's beneath the cursor. Flutter is kind of a special case in terms of toolkits here, because it does 2D on top of a 3D space. I have a demo here, a quick demo that I recently did. I'm gonna share my screen, and I hope everything goes fine. All right, so do let me know if you can see my screen. You probably can see my cursor, but you do see my screen, I hope. Because at least I can see my screen.
We can. Go ahead.
Fantastic. Thank you for confirming that. So what I'm going to do here is I'm gonna pick like this window. And like it's a 2D toolkit. It's a 3D toolkit doing 2D stuff. So I can do like, for example, rotate this window in 30 degrees, and it does this weird thing. And you know, fantastically, you can still like interact with the window with all the transforms in place. So it still works with like stuff like this. I can like open new tabs and etc. Which is like pretty nice as a toolkit. It has to deal with a lot of matrices, which I'm going to talk about later. But it has basically to deal with tons of matrices everywhere. But it also can do a lot of cool stuff with it. Yeah, that's Clutter. Let's move on to the next topic. Recently, Mutter received some improvements to the frame clock, specifically to the frame clock scheduler, where like we had, it's easier to do this with charts, of course. So these strips here are the vsync events from the monitor. And it basically, when an application draws, it tells Mutter either through Xarg or through Wayland protocols. They tell Mutter about a new buffer, and they have to do this like until this green strip here. If an application like a video player is running, and then it has a frame ready, and it sends the frame like here, this frame is not gonna be in this like application frame. It's not gonna be shown in the next frame displayed by the monitor. Instead, it will skip to the next one. There's a small delay here. We call it the sync delay. You can see here after the v blank. This delay is there so that we can read input. We give a chance for input events to arrive and be ready at the very next frame. If input events arrive like here or here, they're also going to be displayed on the frame after that. So we got some latency here. But at least we give a chance of these events to arrive here. But that's the old ways. Nowadays, we improved this a little bit. It's improved here. So we give a bigger room for applications to draw. So if for example, if the video player like draws something and it draws right here, we're gonna try and show it in the next frame. Draws here, we're still gonna try and show it in the next frame. So it has a much higher chance to not skip the frame. To reduce, it has a better way. It's a better way to handle latency, reduce latency, so we don't skip too many frames. We also recently got a 1 frame clock per monitor, which should, that's a relic. It's basically us catching up with times. It comes from, it turns out that when you're an application, you don't have to do with multiple frame clocks because you're in a monitor or not, the compositor tells you when you have to draw yourself. But when you're the compositor, you have to draw different parts of the screen at different frame rates. So recently, Mutter also got the ability to have different frame clocks for different monitors, which vastly improved everything. Still on the topic of drawing Mutter and stuff. So one of the ways that Mutter has to deal, one of the APIs that Mutter has to use like very frequently is the DRM API for mode setting and page flipping. In the past, we were really not atomic. So if you like open Control Center and modify something, that's gonna be the comments are gonna be issued like immediately. Over the past year, we received an improvement of that. We're transitioning to atomic KMS. And to do that, we are introducing transactional changes. So what's currently implemented in GNOME shell/Mutter is that all changes, they're accumulated in a transaction, but this is a fake transactional KMS implementation because by the end of it, we issue individual comments using the non-atomic API. But that's the first step. So we now like agglutinate events, configure events together, and then issue all of them in a single step. In the future, we want, of course, to use the atomic transactional stuff. So one commit by the end of the transaction, and we are done with it. All these slides were a courtesy of Jonas Adel from Red Hat. Thanks, Jonas. More than that, eventually we want, the current implementation is already like prepared for receiving a KMS thread, so we can submit the KMS stuff, the DRM calls on, we can do that on a thread, in a different thread. It's prepared, but it's still going to be difficult because we have to do a lot of state tracking internally in Mutter, and threads can very easily mess up with that. Another difficulty is that we have, as a compositor, we have to deal with we have to be able to switch between old fallback, OpenGL, rendering for various cases. Like we can support hardware overlay for compositing, but we have to support OpenGL compositing as well. We can, we'll have to support cursor plane, but if there's no cursor plane in hardware, or if it fails to like submit a cursor buffer, we have to use OpenGL for that, and gamma correction and all this stuff. Yeah, most of this code lives under the KMS. Oh, I screwed up. Under the KMS prefix. And since we're talking about KMS, let's talk about planes. So currently, Mutter only uses the cursor plane and the primary plane. Using the hardware overlay plane or the planes in plural, it's going to be a difficult transition because it's going to need some deep surgery. And I'm particularly very keen to try and see how libliftoff goes with it. It's especially tricky because we have to check for a lot of stuff. If internally that particular element has the correct buffer formats, it can be composited. If it can be composited in an overlay plane, whether it's going to be screwed up, it's going to screw up the widget tree or not, or if it's going to be occluded because we cannot, an overlay plane has a series of restrictions that are hard to express with clutter. And the fact that we have basically to try and see if it fails or not is not like very motivating. So that's why we want to like investigate libliftoff and see how it performs in this case. And yeah, that's what I had to talk about planes. Switch gears a bit and talk about input. On Wayland, we use libinput in XCB, as I mentioned before, and they're implemented as seeds. I think the concept of seeds is it's being introduced recently, and this is the abstraction layer that Clutter has. Clutter has like interfaces for seeds, and Mutter implements a native seed for Wayland and an X11 seed for X11. A seed is basically the part of the code that owns the input devices and generates input events that are later sent to the client. And we are currently working towards an input thread. So it's very much work in progress at this point. But the ultimate goal with that is that we want to have an input thread here. And these charts are a courtesy of Carlos Garnachos from Red Hat as well. Thanks, Carlos. We want to have an input specific thread that's going to communicate with the UI/Wayland thread. And eventually, the UI/Wayland is also going to feed back to the input thread. And input is going to, if everything goes right, input is going to communicate with the KMS thread directly as well. So if like something goes awfully wrong in the UI thread, the input thread can still update the hardware cursor, and the KMS thread is not going to be stuck together with the UI thread. So basically that achieves the behavior of the current Xarg architecture. Well, how Xarg behaves, in fact, since the client is not another, since the compositing window manager is not another thread, but rather another process entirely. So there's that. So we want to eventually reach the point where we have an input thread, a KMS thread, and a UI thread. Because that's going to cover a lot of cases. And there are various benefits of having a different input thread. So as I said, no stuck cursor when the UI thread is stalled. We can deliver better high frequency devices, events. And in general, it's just good to have something well implemented. And the last topic that I wanted to cover here, the last big topic that I think it's relevant for us because it does touch some kernel APIs as well. Oh, some APIs that are related to kernel, is screen sharing, because Mutter implements screen sharing in terms of a pipewire based streams in the plural, because you can have more than one stream. And basically pipewire pre-allocates a number of buffers and cycles through them. And it also supports streaming metadata. And recently Mutter gained like a super fast path, which uses DMA buff sharing to share like textures with clients. And the slow path is basically still GL read pixels. The slow path isn't drawn here, so we have a buffer here on the GPU, and Mutter has to download this buffer, send to a client. Here I'm using OBS Studio as an example. It communicates, it gives the buffer to Pipewire. Pipewire does all the buffer negotiation, stream negotiations stuff, and then feeds the client with the buffers. And the fast path using DMA buff is, we have a buffer here in the GPU. We create a copy of it. Pipewire gives us asks us to create a queue of buffers. So usually that's 16. I'm using last here just to demonstrate it. But we create all these GPU-based buffers, and we pass just the DMA buff, FD, to Pipewire. And Pipewire gives this FD to the application, which can then create an EGL texture on top of it and render itself without downloading the texture. These buffers, they are destroyed by the end of the stream, so they are reused while streaming, which makes up for a very, very consistent smoothness on the streaming side. I have a demo for that, prepared specifically for for this talk. I'm gonna again share my screen over here. It should be working, I guess. No, it is not, I suppose. Yeah, I guess it isn't. Second charm is a charm, isn't it? All right, let's try again. One more time. Oh, I canceled it and went it back. There, so now it should be working. You don't see my cursor, but you should see it here. Linking with the previous talk. So I have this prototype of OBS Studio running as a Flatpak. So I'm gonna run it with Flatpak. Run OBS Studio. There you go. It automatically detects it's running on Wayland. And this is the screen sharing portal that Alex mentioned in the previous talk. So I can choose which monitor I want to. You're probably seeing it's eating a lot of frames, but I can choose which monitor I'm going to share. The other monitor, which I'm presenting over here. There you go. So yeah, this is me sharing my other window over here, and as you can see, it's running at 60 FPS with 15% CPU. It should be actually even less, but I'm streaming it twice, one with Pipewire and one I have two streaming sessions running at the same time. This is like a massive improvement over what we had, but it has its own limitations. This is the demo, by the way. Using portals, I can also do choose a specific window, this is still, again, the portal, so I can choose I don't know, let's select this one, and I'm using this, and then I'm screencasting this specific one. It's sharing the cursor through metadata. That should be a lot of mass that you're seeing here. My screen's fully. So it's using metadata, so it's still hardware cursor, hardware accelerated cursor. It's pretty much the state of art right now. But again, it has various limitations. All right, this is the demo I had. Go back to the presentation. No NVIDIA support. To the best of my knowledge, I cannot share DMA buffs on top of NVIDIA. At least not like this. And also no X11 support. In this case, because I just didn't implement it and nobody did as well. Some thoughts on this. So when implementing this, the GBM API is fantastic. Massively easy to use API. The limitation of this proof of concept, right? So what's GBM? It's a generic buffer management API that that is the one that NVIDIA doesn't implement and everybody else basically implements. It allows me to create buffers on the GPU side. This is what Mutter uses to render itself. It's in the GBM KMS layer. And it's what we use to share the DMA, both FDs with Pipewire, which then shares it with whatever client we want. However, Pipewire itself doesn't support sending really important DMA buff information, such as modifiers. It shouldn't be hard to edit. It should be a great task to start contributing to it. But it's currently lacking and doesn't allow us to use really most optimal setups for screencasting in this case. So we have to use a linear, an X BGR 888 buffer with a linear modifier everywhere, which is super not optimal. But it does work, it's still orders of magnitude faster than downloading the buffer with gel read pixels or something like that. Right, you can check all of this. This is currently not merged. You can also try the Flatpak, demo that I did using this command here. And yeah, this is what I had for screencasting. So some other plans that we have for Mutter. Finish the transition
like a question there, Judith from Wade.
Sure. So Wade is asking, will apps need to be updated to support Pipewire DMA-based screen sharing? Slack in browser, which currently are unable to share when running inside Wayland. In general, apps should update to use Pipewire everywhere. The screencast that I did was using Chromium, which has an optional Pipewire flag where it also talks to the portal exactly as I did with OBS Studio. It does with the portal, so it asks Mutter to share the screen. Mutter sets up a Pipewire stream and passes the information to Chromium. In this case, I believe that apps that use Chromium at some level, so for example, what's the name of that? It's
Electron.
Slack is sorry?
Any Electron-based app?
Yes, precisely, Electron. Electron-based apps should have support for that if the app that is built on top of it opts to, again, to the best of my knowledge. So yeah, people should be, I think, for the future, we want to use Pipewire everywhere. So we have portal implementations, as Alex said in the previous talk. We have different portal implementations. So what you saw here was GNOME's implementation of the portal, which shows like a GTK window asking you to choose stuff. And then KDE also has a portal implementation, which, as to the best of my knowledge, recently received support for DMA buff sharing as well. So, and WL Roots also has support for these portals. So I think we are converging to a standard here, which is quite fantastic. In my experience, it works. In practice, it works better than X11 shared memories. So there are a few questions here in the chat. Does this work with GStreamer Pipewire element? It does. In the past, I was using the GStreamer Pipewire element, but that kind of forced me to download the buffer to the client, from Pipewire to the client. And then I recently reworked the OBS plugin that I've showcased here to use Pipewire directly instead of the Pipewire GStreamer element, so that I could create an EGL texture from Pipewire directly without downloading anything and just displaying it. And that's why it's so fast, because there's no copy to RAM involved. There's another question here. No, there's not a question. As in, it would need to modify the pipeline to not download the buffer by accident. I'm not sure if it's possible to implement this with GStreamer, the Pipewire GStreamer element, without downloading the buffer. I'm honestly not sure. I tried in the past, I couldn't make it work, so I decided to just not use GStreamer in the first place and use Pipewire directly. It's not a big code. It's less than 1,000 lines of code. Most of this plugin is like less than 1,000 lines of code, and the Pipewire part of the code is less than 500 lines of code, so it's not that hard. So there's that. So other plans that we have for Mutter: finish the graphene transition. Graphene is basically, I'm going to talk in the next slide, so skip this one. Retain tree rendering. So instead of immediately drawing elements on the screen, we create a tree of rendering commands and issue them afterwards. It allows us to optimize a few things. And one thing that I didn't showcase here, but I could if there's an interest in that, is profiling. Mutter does support being profiled by sysproof. It has like frame time counters. It can count like how long did it take for a specific frame to render? How much did it take to figure out what's beneath the cursor? How much did it take to like lay out the actors on the screen, etc. But we want to have deeper and more detailed profiling for the future, because profiling is good. Profiling is fantastic, and optimizing what we know to be slow is the way forward, instead of guessing stuff. So Graphene is basically we are transitioning to Graphene, and Graphene is a library that has graphics data types, such as like quaternions, matrices, 4x4 matrices, points, rectangles, 3D points, vectors, frustrums, everything graphics related. And it has some pretty interesting platform optimizations, such as like vector operations for GCC, ARM Neon, SSE, and it's fantastic. It's a fantastic library, but being a massive code base, and having significantly different semantics, it's been hard to transition to use Graphene completely. Specifically, Cargo Matrix and Graphene Matrix, they have different semantics. They are laid out. One is column first, and the other is from row first, and it's kind of hard to work around that. So any help that is appreciated. And that's all that I had here. Do you have any other questions? I think I'm 5 minutes late, I guess. But if you have any other questions or comments, or if you're interested in knowing more about something, do let me know. Oh, I guess I should also look at the Telegram. No, the other one, the Rocket Chat. Well, looks like no questions around. So, if anything, I'll be around all day in chat and here. If you want to talk about something, just let me know. Thank you.
Thank you, Georges. Looks like we have some free time here. So if you want to get a cup of coffee or anything else, or if you just want to just ask questions anyway, Georges will be around. So thanks for your talk. Super interesting. It was really great to see some of those demos and some of the complexity involved in Mutter. It's not generally exposed to most people how much engineering work goes into just your desktop, right? On both KDE and GNOME. So
Anytime. I'm happy to be here. Thanks, folks.
I've made George's slides available for download right here if you'd like. Otherwise, they've been published on the main website as well. And Shri, I've uploaded the slides for the next presenter as well.
thank you, Guy. Appreciate it.
How much time do you have before the next presentation? I haven't looked at the time slot.
About 20 minutes.
20 minutes? So I'll
Yeah.
put up a we're on a break slide unless somebody has a question or a topic they want to insert here. We can we can let the others know that that we're on a break right now. Yeah, I think, if I'm not mistaken, Shri, I think it's the other way around. I think that the plasma presentation was supposed to start 8 minutes ago, not the other way around.
Oh, okay. All right. Then you're right.
You're a few minutes behind. Thank you, Thomas, for pointing that up. I wasn't completely sure, but I didn't want to be assertive.
No. I'm not perfect. So yes, Bhushan, if you wanna get.
What we'll do is we'll make sure people are back.
So,
Are people around to? Are we ready to start? I'll just put up a quick poll here. Please answer if you're ready to start. And then we will, if we have critical mass, we have 41 people in. Again, for those of you that stepped away, we're just looking at maybe getting started soon again. So if we get to 50% respondents, we will we'll get started. We're almost there.
we have plenty of time on the back end anyway. So.
Well, it's the only thing standing between that and some people's beer as well. But I think we do have some time. Yes, I'm not overly worried. But we don't want to start without some of the people here that just assume we were going on a break.
Yeah.
So far, 16 people have said they were ready for us. Thank you, everybody, for being queued up. And sorry about that little time management thing. 18 now.
Yes,
We'll
my
see which,
fault.
beverage of choices. If your coffee's been refilled, if your green tea, black tea, white tea, blue tea, or you're already on beer or wine, something harder already, you're pretty hardcore. 19 people. I said at the halfway point, we just need a couple more people to answer that they're ready, and I will make you presenter, Bhushan, and I will upload the slides for you as well. And we have them. According to the poll, over 21 of you are ready to get started again. So with your approval, Shri, I will go ahead and get you started again.
Sounds great. Let's do it. As soon as Bhushan he needed his 1 minute. So as soon as he's ready.
There we go. He is queued up, so we'll be ready to get started as soon as you want. And thank you again, Thomas. If it wasn't for you, I would not have said anything. So you are you are the moderator, the real one here. Blue tea is a variation of tea that basically sits between the white and the green tea preparations. It's fairly rare, but if you look it up, it's actually a pure tea leaf-based tea preparation that is quite unique. Jason, welcome back. Sorry about that. Beckett, I'm here for that. Hey, we can see you, and we see you're muted on the platform. That is one efficient chair you have. I will mute myself, and over to you.
So, hi, I'm Pushan. Can I start actually, or?
Yeah, I think you can go ahead. I think a few more people said they were back, so you have over 25 people here ready for you to present.
You're a little bit quiet there, Pushan. Do you think you could?
Okay, now can you hear me?
Yes, that's much better. Thank you.
Yeah. Okay, so hi, I'm Pushan. So first of all, like, okay. So first of all, a little bit of introduction about me. So I'm KDE developer and also one of the volunteer sysadmin. And as part of that KDE development, I work on Plasma Mobile as a maintainer and a developer. And I am currently employed by the Systems GmbH, and I'm from Vadodara, India. And so I had this slide slightly mixed up. So slide 3 was supposed to be previous, but yeah. So what I want to talk about is like how we developed Plasma Mobile initially and how it changed over like next current 5 years and some of the super basic architecture details and what advantages Trust Project brings to KDE community, our application ecosystem and development, and like what is the future for Plasma Mobile project and what are challenges we are facing where like Linux plumbers people can help or guide us. So quick introduction about KDE if you don't know it already. So previously KDE was known as like the desktop environment. It was like one of the desktop environment like GNOME, and but over the time we realized that we are no longer into just desktop environment, and we are now like working on almost everything. So we essentially just got rid of the whole full form and now are the community who creates the free and open source software. So we have several products including Plasma. Plasma is like the renamed version of KDE desktop environment, KDE frameworks like set of reusable libraries, and various KDE applications. Those are like from simple card games to super complex video editor, KDE Live, or painting application like Krita. So we have like almost a wide range of applications available in KDE. Yeah. So coming back to Plasma Mobile project, it was announced in July 2015 at one of our annual conference meeting academic, which by the way is happening on 4th September this year, also virtually. So main reason for Plasma Mobile project was to provide a completely free and open source mobile platform which respects this privacy and freedom. I mean, it's kind of slightly awkward where there is a totally Android track in this conference, and I'm presenting on one of the alternate mobile system. But yeah, the idea behind that was we will not have any kind of trackers built in software or actively will try to provide privacy and freedom to user. Our initial prototype was based on LG Nexus 5, widely known as Hammerhead. So our slides are taking forever to load or something. Yeah, so you can see this, how Plasma Mobile looks right now. It's you can actually visit the website and see some screenshots there, but these are just very quick photos. Yeah, so for initially, we used LG Nexus 5 as the reference device. One of the main reasons for selecting this device was back in 2015, it was supported by most of the alternate mobile systems like Shellfish OS or Ubuntu Touch or even like Lineage OS, and it was extremely easy to like unlock this device. You just type 3 or 4 commands and you don't have to get any kind of key from the vendor or anything like that. In general, it was like super hacker friendly. We were using Ubuntu Touch 15.04 as the base system. It was like 5-year thing because like we were taking out Ubuntu Touch system and like removing all of the user interface part and adding our software. So I mean, since it was a prototype, it was mostly not very well architectured, I should say. And one of the major point was like it was making use of Android binary blobs and drivers. The main reason for this was like at that time there were no alternatives available, or more like there were no options available rather than like using proprietary binary blobs. But one of the nice things was that we were also able to run the whole thing on your desktop or laptop system, so you can essentially just so I see a question in the big blue chat from the Krish. Does this project use libraries to use Android binary blobs? So initially, yes, but this is not one of the hard dependencies. I mean, like I will come back to this topic in one of the next slide. Yes, I mean, like initially we were using this binary blob, so we were actually making use of libraries, and so since like those drivers were based on the Bionic libc, and so we had to use libraries. But over the years, the situation changed in like device market, and some situations changed. What's wrong with this? Yeah, so basic architecture details was like we are using Queen Variant as a compositor, TRM or GPM. We can use the TRM backend of the Queen Variant on the supported devices, or for example, HW Composer backend. So HW Composer backend actually uses the libraries to communicate with Android binary blobs. We have this Plasma shell, which is basically a user interface loader or main user interface part, and it can load various. It can also run the mobile. It can run the mobile. It does have like various shell packages you can replace or like run with. So we have this mobile shell package which gets loaded in the. So there is also quick controls and Kirigami for application development we use. So coming back to architecture, this is not part of slide, but I just said the message in chat about post-market OS support for LG Hammerhead Nexus 5 is excellent and runs Plasma Mobile on top of mainline kernel. So yeah, so we initially started with Android binary blobs. At that time, I don't think like back in 2015, MSN 8974 based like Nexus 5 was not supported in the mainline, but at later point, I actually submitted really initial DTS to have it like I submitted like really initial details with just basic where it supported basically URT, and then after that someone took over work, and now Nexus 5 is like one of the really nice device which supports mainline kernel, and you can run like reasonably new kernel like 5.4 compared to previous kernel 3.4 or better. So one might think like why one of the desktop giants decided to jump into this mobile port, and what advantages we were looking forward to. So one thing which we got from this whole Plasma Mobile project was the devices which we wanted to support were slightly resource contained, because I mean like they probably had powerful CPU, but not that's a powerful CPU as your desktop or laptop, and so we needed to make our whole of our user-space software much more performant, and like do various performance improvements in many parts like shell loading or like loading from the slow eMMC or something like that. We also, as part of Plasma Mobile project, we also got better touch input support in applications and shell. Also, since like we were using Variant Compositor, there were various improvements in our parent support, like proper input method or proper virtual keyboard support, or I mean, depending on the requirements of Plasma Mobile, there were multiple pages landed in our compositor. Also, Thomas asked question in chat, like did some of these improvements go back to KDE and Wayland? So yes, they did go back into KDE and Plasma. So so the idea behind Plasma Mobile project is like we are using 90% of same stack as the desktop. It's just a slightly different user interface where like you want to use it in your hand instead of like using it with the keyboard. So there is just slight difference of user interface. Otherwise, most of the backend parts are like almost 92-95% is same. So if you improve something for Plasma Mobile, it ultimately also benefits the desktop and Wayland section. So I don't know why my slides are kind of loading super slow, if it's just the graphics or something. As I mentioned like previously, we are using like Quick Controls 2 and Kirigami as the toolkit, and CMake QMake is like choice of the preferred build system for like if you develop app, use CMake or QMake. It is recommended, but like no one is stopping to you to use Makefile or Mason or anything. And we are supporting like almost all bundle formats, mostly because those bundle formats can be run very simply on desktop anyway. So we don't really have any kind of restriction on what you can run. You can run something of Snap or Flatpak or App Image or even out of Docker, or basically just go wild. And you can also like use native distribution packaging for the distribution of your applications. Yeah, so as I mentioned, like back in 2015, the situation was totally different compared to what is it today, and I'd say future for Plasma Mobile looks brighter than ever. Various phone vendors are mainlining their kernel trees, like various Android vendors who sell Android devices are putting their kernel patches for inclusion in the mainline kernel. There are active mainlining efforts supported by those companies. Some of the phone vendors are creating devices which runs on totally open drivers, like Prism Librem 5, which is based on IMX8, and PinePhone, which is based on Lunar A64. So in general, phone vendors are working on getting more open devices into the market, and I think that's a very good sign for projects like Plasma Mobile, or let's say Ubuntu Touch or Purism's Fosh. Also communicating is like mainlining of the shelf devices, like as in the chat we heard about Nexus 5. Like Nexus 5 was one of the off-the-shelf device, but at some point community decided like, hey, since like MSM 8974 is like very well supported in kernel tree, why don't we support the Nexus 5? So right now, like with like almost 20 patches, you can run basically fully mainline kernel on Nexus 5. And you need to like apply 20 or 30 patches on top of it, which are not mainlined, or kind of they are maybe like hacked, so cannot be mainlined. So yes, in general, I'd say device vendors and this whole community involvement is helpful for Plasma Mobile and its projects. And so from the software side, there are some challenges and work areas where we are struggling, and or well, not exactly. There are some areas where we are struggling, and there are some areas where we can improve a little bit and see how we can get something better. So these are like application lifecycle, hardware enablement, and bring up, and also like power management. So that in terms of application lifecycle, I'm not talking about development lifecycle, but more of like what does this application do after it is started on your mobile devices. So as I previously mentioned, the mobile devices are like limited resource devices. Like right now, you can get like devices with like 6 or 8 cores, but still they are much limited resource wise. And also, like you don't really want to have applications which use like full resources and impair basic services like call services or something like that. So you want to prevent application from consuming the excessive resources, or you want to basically give more priority to like application which user is interacting with, or like if you have some application which is running in background doing literally nothing, and like user started it like 2-3 days ago and haven't interacted with it, you want to like kill this unused application and free up the resources for other applications users might be using. So one of the solutions which we have worked on is like putting the application in the various C groups. There was also talk from Benjamin, who is here, about the very same topic in this conference. So what we are doing is like we are putting our shell and our various system services and application in the specific C groups, which then we can control. Like we can always provide slightly better priority to shell because you want this interaction to be as smooth as possible, and then provide a priority to application running in the front. So at this point, this is more like a theoretical. I mean, like all the infrastructure is there, but we have not like integrated it fully for Plasma Mobile. But this is something we want to work on in the future. And there is challenge of hardware enablement and bring up. So some of the, I'd say most of the off-the-shelf devices where we can possibly run Plasma Mobile is based on Android. So to run like traditional GNU Linux system, or well, not Android system, because yeah, it's not Android system. If you want to run on those off-the-shelf devices, you need to deal with some challenges, like these devices might work better with binary drivers or proprietary hardware abstraction layer. So I get a question from the chat. So kill unused applications running in the background. Does Plasma PTC support full application, as in apps are a way to save on quit and restore on launch without having to implement everything manually? So as far as I know, I mean, like there is a session management thing, but that's a slightly different topic. So I say I don't really have information about this, but I'm 80% sure that answer is no. We don't actually have support for this, and we may probably need to implement support for this to have this functionality. Okay, so like as I shared, on the off-the-shelf devices, you have binary drivers and hardware abstraction layers from the Android. So you generally cannot easily have full functionality working. Like some devices might have like camera functionality locked to Android binary drivers and things like that. Also for phone, of course, you need to like have a calling functionality or SMS, or yeah, so for that you need modem. And on the like newer devices, modern devices still continues to be black box. That is like most of the time you need proprietary real RIL implementation to be able to talk with the modem, uh, some modems support the QMI interface, so you can use the Kubi driver and like have calls and etc. working. But it's still kind of area where it's not that yet, and it would be nice and it would be lovely if this is the area where we can improve the most, I guess. Also, the downstream kernels, I doubt that there are new devices in the market which uses super old version of the downstream kernel, but still they are like multiple, sometimes years, like 1 or 2 years behind what is the current version, and so you cannot easily make use of the newer kernel features or things like that. I mean, like when we started working with Nexus 5, it did support only 3.4 kernel, and that kernel was like end of the life if I remember correctly, at least it was end of the life already when we started working on it. But yeah, we did not have any actual choice. So yeah. So this is something to where also we can improve on. Nice. Okay. Another area is like power management, where it's kind of not exactly problem of the Linux itself. Like Linux itself does have really nice infrastructure for this, but traditional desktop environment like Plasma typically assumes that the target device you are running will have like huge source of power available, like giant batteries or tire. Like it is just plugged into wall, so you don't really think about the energy consumption most of the times. And even in the case of laptop, it's generally like energy saving is mostly about, yeah, so 5 minutes left. Okay. So energy saving is mostly about like turning off screen or like suspending the device. But I say we need to benchmark the various components of our system from energy use perspective. And also we need to like adapt the user space for mobile related power management features like auto sleep and wake locks. This is like this feature comes from the Android into mainline kernel, and I guess most of the Android have pretty nice infrastructure for handling various features like auto sleep or wake locks. So we need to adapt our user space for this mobile related power management features. And yeah, I think that's pretty much it for my presentation. I would love any suggestions or questions about this and how we can improve this Plasma Mobile. So is there any cooperation with Google and especially with Google Fuchsia or is planned in the future? Well, technically we are creating a competitor for Google, so it's yeah, but no, I think it's something we need to evaluate in the future about and see where we can go. So right now it's only proper Linux and not Fuchsia or yeah. Yeah, if you have any questions or suggestions, you can ask that here or in the chat. I will be available in chat for a little bit. It's like 10 p.m. already, so but yeah, I will be available a little bit. And also for pictures, credit to Martin, who provided this pictures under CC0 license. And yeah, that's it. Thank you.
Any questions for Bhushan? I think, just a general thing on power management. This is something both our projects, KDE and GNOME, is very interesting to us in terms of working together, because reducing the number of wake ups and things like that is especially not just from a mobile context, but even on a laptop, right? So if being able to run the longest we can on battery power is something that we can collaboratively work between our two projects, especially if you're trying to build tooling and working with the kernel community for this, because this is something I think is important to us, to be able to be power efficient in the desktop space, right?
Yeah, I guess that's a very good idea in general. So I mean, like, we can still continue discussion, right? Or it's like time out already.
What was it again? I'm sorry.
We can still continue discussion, right? Or it's like time over and we need to hand over.
Our time is relatively over, but we can. Guy, if you correct me if I'm wrong, but we can do a little more extended conversation or anything else. So.
Yeah. Okay. So like, problem with like power management on desktop is.
Go ahead, Bhushan. You can take as long as you want. Indeed, there is nothing after this, so the floor is yours, and you can invite as many conversations as you'd like. The only thing is we're going to try to do a beer/wine drinks thing at some point. It's on the schedule, but the conversations here are more interesting, and I'd like to invite anyone else here in the room, if they'd like to participate, to feel free to do that as well. So, Bhushan, straight back to you.
Okay. So I guess I can change to.
So I also, just on a general conversation, we have a lot of user space engineers here. So if you're thinking about user space, and there's a number of us here, if you have questions that maybe are burning a hole in your pocket that you would like to ask some of us, please go ahead. The floor is open. I do want to be able to take advantage of having some free-form conversations from this point. So.
Yeah, so for the desktop and laptop, assumption is like your device is like never running for. I mean, like some people run device for like continuously, but most of the assumption is like it's never more than like 24 hours. So you put your device to suspend and go to sleep. But for phone, it's not a case. Like for phone, you need to like have it continuously running. So there is some assumptions about like how software should work, like notification support and like push notification support, where like you need to like wake up devices like at every few minutes. And so some of this are infrastructure is like already available in kernel, like using timer FP and things like that, but it's not implemented in user space. So this is something we need to like work on and eventually see it. So yeah, that's what I wanted to talk about, like mention about. Yeah, that's pretty much it from my side.
So Thomas asked about where would you most where would you see the most direct kernel support needed? I would open that to everyone, Benjamin and Bhushan and others, Georges.
I partly did not get the context of the message, I guess.
Correct me if I'm wrong, Thomas. I think you just mean in a general sense, where can the kernel community help directly, at least in kernel space?
Sorry, was this question directed to the previous presenter or like a general
it's
question?
for all of us user space engineers. So that
Okay.
includes you and Benjamin and Bhushan or anybody else who's interested in this, in answering this.
So there are a few places where, at least from my perspective, I'm sorry about the background noise; it's really unexpected. But what I had in mind is, I wanted to have at least someone from the graphics side of the kernel to help us figure out how to implement overlay planes on Mutter. It seems like a really hard task. Lots of restrictions. I'm not the expert when it comes to it, but I'm certainly interested in discussing about it at some point. Yeah, I guess most of Mutter's kernel interactions are on the graphics stack. Input stacks is layered by like input, so there's that. Oh, there's one other thing that we're looking for specifically, and that's mostly kernel work. So unfortunately, I don't have a slide deck for that, but Mutter uses EGL to render, and EGL supports context priorities, right? So like if you have like a compositor should have a high priority, because if it stalls, everything else stalls. So in general, a compositor should have a higher priority. We tried implementing this on Mutter side. So we tried like asking EGL to raise the priority of the contexts that Mutter creates. However, there's a problem with that requires special capabilities. So we needed to like set cap on GNOME shell/Mutter, which is terrible because it breaks a lot of stuff. One idea that's been floating around is having the kernel side somehow figure out that a certain pipeline is going to end up on a display and automatically raise the priority of that pipeline, that specific pipeline. That's something that we cannot really control. If we try to like give Mutter the process the higher capabilities, we lose other stuff due to security reasons, like subprocesses. We have to be really careful about threads and subprocesses and whatnot. So that's something that certainly requires a level of kernel work to be figured out. And that's something that would be fantastic to at some point we sit down and discuss how it should implement. If there's a hint for a kernel that a Mutter can do or something like that. But there's that from my side.
Any other questions or comments or? All right. Well, like we have someone typing.
I haven't particularly heard of lib camera. Let me have a look at it.
I would think like the portal stuff would be an interesting.
I think lib camera was important for the next generation non-USB cameras, right? The MIP or whatever it is called cameras.
That's correct. So
we'll need it in some way, but I'm not sure what exactly it means and how it all fits in.
It's a relatively new project that aims at supporting more complex cameras, so anything that's non-USB. And the idea is to have a full camera stack. So it's not just the kernel drivers, but it's also the user space components on top of that, because there's quite a bit of work that needs to be done by the CPU, and that doesn't fit in kernel space. We also do support the USB webcams, which means that it will offer a unified API through a single stack to any kind of camera that could be found in the device, being it a phone, a tablet, a laptop, or a standard PC.
Sorry.
Yeah, so I was just wondering if anyone had had a look at that from possibly a Plasma Mobile point of view, thinking about how it should be integrated and how we should cooperate moving forward. As I said, the project's relatively new, so maybe it's a bit too early to make real plans there, but at least having a conversation to start with, to check what we could do. And
I would say what you, from your side, could do is working on integrating it with Pipewire. And then from the other side, all the software components should switch to Pipewire to actually connect to the various webcams, and instead of directly going for E4L2. So from your side, that's probably the Pipewire. That's the interesting part.
Okay. Yeah, we have plans to. We already have a GStream element, but we're looking. We will start looking at Pipewire as well. It will likely mean modification of the Pipewire camera API, the one that sits on top of Pipewire. So applications will need to switch to something different. But I had a conversation already with Wim. It was last year actually already at the GStreamer conference. And I know that there are a few people from Collabora who are interested on this as well, so it will move forward.
Yeah, I also feel like this is an interesting addition to Pipewire. Pipewire works in terms of streams and endpoints. So a camera would be like an endpoint, generates content, and other stream consumers would be able to consume the camera, all of course intermediated by Pipewire. So I do also feel like it's going to be a fantastic addition to it, especially because if it's more complicated cameras than simply like reading colors from real world, then it's probably also going to involve, I don't know, sound or other types of events, multimedia events.
Camera side, probably not too much. When I say complex cameras, I'm talking about cameras where you really have a raw sensor and a powerful ISP to process the images, but you need to implement all the algorithms that will give you auto white balance, auto exposure, and all that in user space. And that's not something that we want applications to do because it's fairly complex. It's very device dependent. So that's why we're providing a new framework that integrates all that behind the scenes.
Yeah, there's a lot of stuff that you need to do in the camera there.
I know. Okay, thanks.
That's a great conversation, and pretty interesting. I would love to see that kind of collaboration going forward. Does anybody else have any other burning questions or ways to collaborate? All right then. So I'll make a closing comment on my end. We conceived of this microconference as a way to.
You want to turn your camera on, Tree, maybe, so that people can see you as you're making your closing remarks?
Yeah, sure. All right. So let me make my closing remarks. When I brought up this microconference, there's a general idea of wanting to. Our projects tend to have, over time, been siloed, and a lot of the work we want to do is we want to be able to break out of our silos and start working with the other ecosystems, especially the kernel. Back when both KDE and GNOME got started, we had very close associations with the kernel community, and together we built some great engineering going forward. Over time, we've sort of separated, and this microconference is a way to sort of bring everything back together again. There's a lot of great problems to solve together, and it's one of those things that, at least from a desktop or application experience, we could be a lot better than we are today. And so if my hope going forward in future Plumbers conference that we can work together and actually build a great platform for applications on Linux. Tim Erling says, whenever we have more cross-pollination and cross-communications, we seem to generally come out better. That is absolutely true. And we're doing this even with each other, right? So GNOME and KDE are working much closer together. We have a conference called Linux App Summit. So we are working with other ecosystems from the kernel side. We're also working with the application developers and the people who consume on the user space side, right? So as we build this out, we hope to greatly accelerate our maturity, right, on desktops and applications. So that's what my wish here is, and I hope that I know that on our side that we are definitely interested in coming back. And hopefully we'll bring a lot more of the people who write graphics drivers, the graphics stacks, as Georges was talking about. This is kind of a very interesting area for us. Definitely more on C groups and everything else. So there's plenty of areas, of touchstones that we can work together on. So yes, as Benjamin said, yes, I did mention C groups. So yes. So let's keep our communications open. Let's reach out to all of us, and we reach out to you as well. And hopefully the next conference will be in person, and we could have a lot of these conversations in person, and so forth. So with that, I'm going to close out this micro conference. I hope this was useful, and if you have any feedback for me and for the people here, please don't hesitate to reach out. I'll be on the Rocket Chat, and I'm happy to have conversations on everything going forward. So thank you all, and I also want to thank the organizers of the Linux Plumbers Conference, Elena, Guy, Stephen. Thank you so much for your support. Thank you for accepting our micro conference and allowing us to come back. And that's all I have to say for now. Thank you very much. All right, everyone. Thank you.
Thank you, everyone. Thanks, Shri. Thanks to the organizing committee.